Cool. Long time no see.
Hey up, mate.
Nice to see you.
Likewise. I solved the riddle of trying to get the Zoom link out of meetup.com.
So I do wonder if that slowed people down because like no see. Oh,
Yeah,
hold
I
on.
usually get an email through that says, here's the link for tonight's meeting or something. But the only place I could find it today was actually logging into Meetup and getting it off the event page.
That's what Sander said. Sander said the same thing. So it sounds like
Ah,
Meetup's had a problem now. What I don't want to do is put the Zoom link on YouTube because on Twitter or Twitch, any of those things.
yes.
That
Yeah,
would
we've
be
all seen what
bad.
happens when you do that.
Yeah, exactly. I am slightly tempted to see if I can email people to say this is the
If
link,
if
but
you if you're if you're logged into Meetup and
yeah.
you're registered as an attendee, you can see the link on there if that helps.
Yeah, that's right. Yeah. But I think Sander, because I don't often join these things, I'm normally running them. But Sander
Yeah.
says you quite often get in your calendar invite, when you add it to the calendar, it'll be there. So,
Yeah, I usually get it from an email.
right, interesting.
I think usually like the day before it says, here's the link for your meeting tonight or something.
Yeah, no, I don't know
That's
why
the
that
email
is.
that I got,
Okay.
but the invitation in the calendar didn't have the link.
Hmm,
But I got lots of emails, just as everybody.
okay. Oh, well. Right, I'll start off. So, welcome to Not So OT. There's some new faces here, so thank you very much for coming along. We do have a code of conduct in place. Really, it boils down to that bottom right-hand box of be kind and considerate to others. In the, if anybody feels as though that's not been met, then do send me a direct message in the Zoom chat, and I'll endeavour to put things right and make sure that everybody feels comfortable. But you all look like awesome people, so I don't envisage we'll have any problem there. We have got sponsors for tonight, so I do all the hosting and configuration of all those systems. So my sideline company, PJG Creations, gets a mention there. Raspberry Pi, they help us out with quite a lot of tech and bits and bobs, and so they get a very nice mention there. They're awesome. JetBrains actually ought to have removed that because they've stopped giving us codes at the minute, so I can't give you any codes for JetBrains licenses, sadly. I
What?
need to get back in touch with them. Yeah, exactly. I need to get back in touch with them and get
It's an
that back up.
outrage.
It is an outrage, exactly. I also, it is probably my fault, to be fair, because I'm not very good at giving them away. So probably should do better at that.
I'm
That
not
would
very good at
probably
asking
help.
for them.
Well, yeah, I will get that fixed for when we come back in September time. And Rebel, they are very kindly providing us with the Zoom license that we're all using. So Rebel are a awesome recruitment company in Nottingham who do tech recruitment. So if you're in this area and you need to get a job, do get in touch with Rebel. So there are three MVPs on this call at first count. Myself, Sander, and Christoph are all Microsoft MVPs. This is something that you get awarded by Microsoft. There are, well, there used to be 3,000 of us. I think there are considerably more now, but nonetheless, still a relatively low number of us that get awarded that. And you are awarded that for running community events like this, or speaking at community events like Christoph's doing, or producing copious amounts of blogs like Sander does around content in the Microsoft sphere. And that could be contributed to open source or any of that sort of stuff as well. So, if you're interested in that journey, if Microsoft is a space that you want to stay in and do more in, then by all means, you can speak to any three of us here, and we will be able to help you along with that. Tonight, we have got Christophe Crémon talking about agents of change. Agentic AI is revolutionizing every industry, which is absolutely correct. And then first, we've got myself, that guy, detecting pollinating insects with the Raspberry Pi and the Hailo AI kit. Actually, it's sort of expanded a little bit more to it than that this particular talk, but it will be quite short. I don't want to take too much time away from Christoph's awesome talk. So, with that in mind, I will switch over to my section. We do have more than one of us that are on this project on this call. So, Dave Bostock, who's hiding there in the corner, was also involved heavily in this project. So, he might be persuaded to come off of mute and camera to talk to his piece. But nonetheless, for those that don't know, the Avanade Intelligent Garden was a project that we ran together with Microsoft to celebrate our joint birthdays. So, this year is Avanade's 25th birthday. We got going in the year 2000, so that's now 25 years. And that was a partnership between Accenture and Microsoft. And Microsoft is heavily influencing everything that we do over at Avanade. And so together for Microsoft's 50th birthday and Avanade's 25th, we decided to create something new, which happened to be an intelligent garden at the Chelsea Flower Show. So for those that don't know, the Chelsea Flower Show is organised by the Royal Horticultural Society once a year. This year from May 20th to May 24th. We have 14 official large show gardens on Main Avenue, as it's called. So they get allocated a larger amount of space, and they're there really to show off the best of what can be done. A huge amount of people come to this event over 5 days, 145,000 plus or minus, and a lot of press. So there are press days with royalty and all the celebs and that sort of stuff. But onwards from that, a huge amount of coverage, including 13 hours of BBC coverage. So there was a big team involved in this. And I'm always keen to point this out because although I'm speaking about it, I was a cog in a larger wheel here, a larger machine. So the project was led by Devon Young and Martin Harper and Steve Smith at the top line. They were running a lot of what was done, and a lot of what was good about this project was funneled down from those three people. And then you can see we had a whole selection of other people involved in this, including myself, Pete Gallagher there, and Dave Bostock down there as well. So we will speak to what this intelligent garden is about. So to do this, we partnered with Tom Massey and Jay Arn, who are award-winning garden designers and architectural designers who we'd worked with before previously and who have already won gold medals in Avanade in gardens at the Chelsea Flower Show. So that partnership was specifically designed that way because we wanted to make sure that whatever we put out at Chelsea was beautiful, apart from anything, but showcased the best of what both of these parties could do. This is what the garden looks like, if that plays. So, or looked like, because it's gone now. They have to dismantle it afterwards. So this is Main Avenue before it was open to the public. And this is facing into the garden with the pavilion area at the back. And then you can walk through the garden. And this was designed with, I think, 12 trees in here of different species. And we fitted sensors that I will talk about shortly to each of those trees, as well as a host of other sensors. So we can walk through and then go in a little bit further. You can do it. In you go. There we go. And this pavilion here was built from ash, wood, and mycelium, which is basically mushrooms. It was beautiful to look at, very cool inside, temperature-wise, and how cool it is. And then we can see our section here overtly begins on the wall with these three screens, where we were able to surface a lot of the intelligent data that we were collecting out of the garden. It really was a beautiful place to be. So building it, though, a huge amount of work. You come in a month before and it is empty, as you can see there. So there is nothing. And it's returned to this state afterwards. And a lot of people, builders and joiners and garden designers, of course, and then later all of the horticulturists and gardeners and species experts will come in and plant all of the pretty stuff in the garden, the trees and the flowers, and make streams and things like that. But over this time lapse, which I'm not going to view all of because I think it's relatively long, you can see the amount of effort that has to go into that. That's a good place to finish, that is. Look at that. Love it. So the interesting part for the people that have joined this presentation, the tech, there's a lot that goes into this garden, and the part that I suppose I'm going to be speaking about later, the pollinating pollinator insect AI camera trap, forms a part of it. Outwardly, the biggest thing that got the most amount of interest was Tree Talk, which was based on receiving telemetry from the trees, which I'll talk about in a bit more detail later. But we had sensors and also third-party data, and that was ingested into Azure. There's Craig. I see Craig coming on camera. Hello, Craig. This is data ingested into Azure and then processed and stored. And then we were able to then use OpenAI on the other side to be able to query that data and get a more human response from it, which was really cool. You can, if you like, go to that address or scan that QR code, and you can today talk to a simulated version of the garden still. So this is the live app that we had. So by all means, go and have a look at that. You can ask it questions. Funnily enough, this even ended up on a UK satirical political comedy show called "Have I Got News for You?" as an answer to one of those questions. Even so, the amount of coverage we got was incredible. Those pavilion screens look like this. So on the left, we had a map of the garden with the trees that we were monitoring. There was another layer that showed the other sensors as well. In the middle would be a particular tree that was highlighted in green here, and the information about that would then be surfaced on the right-hand side. So the type of tree and the data that we were reading from those sensors. A lot of that was fed by these tree tags by ePlant. Now, these were really interesting sensors that use LoRaWAN to communicate back to a gateway, and then we had an API that we could hit to get that. And they measure how much the tree's growing using something called a dendrometer. So trees grow from the outside out. The bark regenerates and regenerates and regenerates. You screw a tree sensor into the tree, and then there's a little sensor that will get pushed out by the tree growth essentially, and we can measure the micrometer daily growth of the tree here, which is a good indicator as to whether or not the tree itself is healthy, and likewise the ecosystem that it is in is healthy. There's a temperature and humidity, which will satisfy our good friend Cliff Aegis. He loves that particular sensor, but this one, really good use for it again, because the temperature and humidity of the garden will dictate how it will survive into the future. And it would also have an accelerometer. So if say the tree roots had become destabilized and it was starting to lean, we could get early indication of that as well. And it was all solar powered, so it didn't need to be plugged in, which was great. Now, this is a little bit in the presentation where we try and persuade Dave Bostock to come off mute. You may speak during your part, because this is the part that Dave did. Now, it was awesome. The amount of work that Dave did, you will see, and it was just brilliant. Did you want to speak through this piece, Dave? You are
Yeah,
more than
why
welcome.
not? Why not
Go on
indeed?
then.
Yeah,
Yes.
so the cars, yeah. I ended up doing the sensors, and because sensors and data is the lifeblood of any system like this. As you noticed before, we had the tree tags from ePlant, but this was more along the lines of getting hobbyists involved to show that actually you can do an awful lot with stuff you have lying around the office, if you're a geek, that is. Next slide. So, yeah, we wanted to measure everything. Not particularly practical. We didn't have very long to do it. It's only a part-time project. For example, to measure photosynthesis, that's off-the-shelf device, but that is $65,000 and a 6-month lead time. So we had to kind of limit ourselves to what we could do. So the sensor types there that are marked as soil, that's what we mainly did, and air pollution. The water sensor we didn't finish completely, because it ran out of time. And of course, growth with ePlant. Well, next slide. So when it comes to architecture, it's fairly straightforward. So we have, as Pete mentioned earlier, we have these all canal services. It's ingestion functions. On the left is your function, one that polls the data to pull back from the web API and pull back data from the ePlant API. And then we have slightly more fun stuff. So we have Pete's Raspberry Pi AI Pollinator. And then at the bottom left, we have what we call the GEM sensors, so the garden environment monitor. It was easy to keep calling it a soil sensor, which was measuring the temperature, humidity, pressure, and the soil moisture itself, using a variety, using a couple of sensors, including the same BP280 and AHM20, I think it was, device. And that sends information directly into the IoT hub. We also, because this also is about off-the-shelf stuff as well, you've got a whole range of cheap sensors that you can buy that will just interface to a home assistant. So air sensors will air pollution, they'll pick up particulate matter, free carbons, oxygen, carbon dioxide, etc. So for that, we actually just wrote what we call a virtual device. So you could just configure it so it picked up any other sensors from any other devices, and it came in as one single virtual device. as that just made it really easy to interface and just get all the data from anywhere. It doesn't really matter how many sensors you have. If you go for like the one in the middle there costs like £2 and does temperature and humidity, and over on the right you've got water sensors and air sensors, etc. So something you can buy relatively cheap off, but still actually use it to integrate without having to worry too much about writing your own Home Assistant plugins, etc. So when it came to the soil sensors, it's paper to production. So we literally went all the way from paper all the way through to producing circuit boards in a few weeks. We used off-the-shelf components, so it was all plug and play. So it used to be 32 dev board, the well-known capacitive soil moisture sensor, temperature humidities, batteries, case. We were going to do pH chemical measuring, but that really requires measuring reactions of certain metals in the soil, and that wasn't so great as a long term. You kind of say you do once in a while, not regularly, because it leaves metal salts in the soil. Move on, next page. Yep. So yeah, obviously good old prototyping at the top left. Sorry about my dog barking in the background. And then we moved from prototyping and good old project to very good with my terrible soldering, to producing the PCBs using a CNC. And then for prototyping, and then finally on the bottom right, you have some very simple circuit boards sent in from a prototype manufacturer. Next slide. Yeah, so end up in my office, end up with a production line effectively of 3D printer for the cases, CNC producing PCBs. Yeah, it's all fun. Not exactly something I normally do on my day job, I must admit. Go to the next slide. You can kind of watch all day, which is handy because I did. And then finally, we have the kind of finished product, happily been sitting super good at the bottom left. It wasn't quite perfectly designed. Very large. They connect via Wi-Fi to the network, send data into the hub. A couple of extra little challenges around battery life. The deep sleep of a SP32 wasn't quite as advertised. We ended up adding in some extra modules to act as a watchdog timer. So it moved from like 40 milliamps current drain to 40 odd nanoamps, which obviously meant we went from a few days battery life to a few weeks or months as it wakes up every sort of half an hour or so. The next slide. And then you have the real world issues. On the left there, you can see that one took a fair bit of time. The CNC didn't quite cut the copper on a couple of runs, only visible under a microscope. It was all shorting out. The C3, we had a fault. The Wi-Fi wasn't working at its minimum voltage. So again, we had to step up. And of course, it was absolutely fine in thunderstorms in my garden. 15 seconds into putting the first one into the garden, it got submerged in a puddle, which broke it. That was just one. Hey, prototypes, that's what it's there for. So yes. The rest were fine.
I feel partly responsible for that because I was there when that happened, but I couldn't really stop it from happening.
Next slide.
Yeah. Actually, this kind of towards the end of Dave's part here, in that this was probably one of the best photos. There was another one actually front on that I preferred. This is the one that made it into this deck where Dave was sitting. So this is at the back of the pavilion, isn't it, Dave?
Yes, it's actually in the garden. I'm soldering up a couple of PCBs.
Yeah, there was a fair amount of work done in behind the pavilion there. So it was kind of fenced off with a gate so that we could be getting on with stuff like this out of the public eye. So this is obviously still before all of the public came in, but there's a huge amount of effort going on in the front there from builders and joiners, and as I said earlier, so we tended to work at the back end of the pavilion here. I was actually on the roof of the pavilion half the time doing my Pollinator camera part and looking down at Dave doing his cool stuff down here, so it's quite funny to watch. There was also London plane trees there, which made everybody in the whole place cough. The Chelsea cough, they call it, and it was awful. It got in the back of your throat and it made everybody cough. That was probably the worst part of it because it was not nice to be in that particular environment at that stage because it was boiling hot that week as well. If you remember, it's like this week, but down there. So this is fitting those sensors. So we're planting sensors there. So these are the sensors that Dave's talking about that we fitted near the trees. Temperature and humidity and soil moisture sensors. And then that video you saw in the middle was fitting tree tags. You have to screw them in, as I said. So that's what that piece is. And then the AI Pollinator Camera trap. So this part of the garden really was a follow-on to a system developed by the RHS called fit counting, which is flying insect time counting. It's quite a manual process that humans do generally. So you have to take an area that's 50 centimeters by 50 centimeters square and look at that area. So obviously there needs to be a plant in that area with a flower on it, ideally. And you count the number of pollinating insects that come and land on those flowers at any particular 10-minute time period in this case. And then you write that down and you send it to the RHS, and then gardens across the country can get involved in this. Now, we could have done that in theory at the garden, but that would have required somebody to be there the whole time doing this, which was impractical. And as we're big geeks, we wanted a way to be able to automate this with AI. So that's what we did. And in fact, the results of that have ended up in this month's Raspberry Pi magazine. So I think it's available to download now, potentially, or if it's not, it'll be in a week's time, the PDF, or you can buy it in any good WH Smith's and take that home with you. So 4-page feature in there describing some of the stuff we've done. What you can see on the left-hand side there is an actual video captured by the system of a bumblebee. I became quite enamored with bumblebees, actually, because I saw quite a lot. It seemed to be more bumblebees than any other insect coming along through the garden. But you can see that was able to capture the bee itself and draw a box around it, but actually it captures a lot more, and I'll come to that in a minute. Now, as far as tech's concerned, normally it would just be geeking out, but because this tech goes into in the end, a gold medal winning Chelsea Flower Show garden, everything that's in it has to be beautiful. The pavilion and the housing for our AI camera trap was designed by Sebastian Cox. And if you're in that zone, you'll know how good that guy and his company are at creating beautiful structures. So to mimic the rest of the pavilion, it was designed to have a similar style, and we placed it on the top of the pavilion. So on the top of the pavilion is a wildflower garden, or was, and you can sort of see that in that top left-hand image there. And we'd planted flowers in there that were pollinating insects would be interested in coming along and having a look at. And so we housed our Raspberry Pi based system within that beautiful looking box. It was quite fascinating to watch that because they actually brought the boxes down empty and then wove in the sides on site in that area at the back. It was quite cool. I was geeking out. They were surprised I was geeking out as much, but it was just beautiful. That box was beautiful to look at. But as far as the tech was concerned, actually, we've got a Raspberry Pi and we've got the AI kit or AI Hat Plus Hailo 8L NPU driven hat that sits on the top of a Raspberry Pi 5. So this was a 16 gig Raspberry Pi 5 that we used for this, although 8 gig is fine for it as well. And the process to get the model trained is actually quite convoluted in the Hailo NPU requires a HEF file format, Hailo executable file format to run. And you don't get there very easily. There's a process you need to go through. So a lot of this was done on a Windows PC using WSL, Windows Subsystem for Linux. And within there, you're running most of the applications. Now, I could have helped myself if I'd gone out and bought a nice powerful machine and put a decent graphics card in it and Linux, in that I wouldn't have to use WSL and it would have sped some of this up. But I've only got the one machine here and it's got Windows on it. So I didn't want to dual boot because there can be problems nonetheless. That's how it was. So it's all in WSL. So you start off with training data when you want to be able to create these models. And of course, that's pictures of flowers and bees, and in our case, also butterflies. And then you need to draw a box around those particular items. Now, I can show you that because I have a window open all the way over here. This one here. So this is Label Studio, and that allows you to be able to take an image and then draw a box around it. If it's going to load, come on, you can do it. So this is an image here. When you load, there we are. And you can see each of these blue boxes, they are flowers, obviously. And then down here, there's a green image that's difficult to see, but that is a flying insect. So we were capturing pretty much any flying pollinating insect and calling it a bee just to keep things simple. So you do this for all of your training data, and then you export that from this application to essentially a set of files that you can use for the next step. So once you've created this set of files for the training data, you have to leap into Docker within WSL, which feels a bit Inception-like. And then you have to use then something called a model zoo. Now, Hailo have got a model zoo available for you to use, and that's here. And there's some links for all of this later, which I'll get to, so don't worry too much about that. But what you've got to do is start with a known model that works with the Hailo infrastructure, and that's essentially what they do here. So they give you the facility to be able to do that and retrain the custom data set based on their set of models. So I use something called YOLO. So you can see here, this is that YOLO V8. There's many different ways of doing this. I just happen to want to use YOLO V8. So it worked quite well for us. So you take that set of images and their original model, and then you retrain that model with your own images and help it to understand what the bees and the flowers and the butterflies actually look like. So that's that section. Now, after that, you have to convert that to an Onyx model, which is another sort of AI model. Now, these are really good at doing detection mainly. So what we're doing here is finding the presence of these. We're not categorizing them because there are many different types of bees and butterflies and those sorts of things out there. The next step will be to do recognition as well as detection, but that's version 2 of this. So to recap, Label Studio to create that pack of training data, Docker and into the Hailo model zoo, and a retraining exercise to take that data and a known existing YOLO model to create a model version that recognizes bees and butterflies and flowers. Convert that to another type, Onyx, which is a more open model. And then from that point, you can convert that to the Hailo executable format. Now, labeling a lot of images can take an hour or so. Retraining a model can take an hour or so, and converting that trained model can take 2 or 3 hours. So the whole process around that loop could take a half a day, but actually a lot of it was just waiting. But once you've done that, then now you've got a HEF file. And if you follow the instructions, which there's a link for, you can get everything you need on the Raspberry Pi setup to be able to use that HEF file to do detection. And that's essentially what we did there. Now, once you've got to that point, here's one I made earlier. So this is my Raspberry Pi set up here. And although I've got it set up with the camera, it's no good because it's pointing at my office wall where there are no bees and flowers. So you don't want to see that. But you can actually run through videos, which is really useful when you want to go back around that training loop. So here's one I made earlier. If I run this, then you can see here that we've got an image, and that's that same one I showed you last. So you've got some flowers and then a bee, albeit it's actually a hoverfly, landing on that flower there. So each of those flowers is, and I'm using just a plain video, and we're overlaying those boxes. So each of those flowers and its percentage of are you a flower is there. And the bee is detected separately, and we get a bounding box around that with the percentage as well. Now, when it's finished, what I've got it set up to do currently is slightly different in that it's creating a video file of that detection. So we're doing a few things. One is that we're looking at those bounding boxes, and if a bee overlaps with a flower bounding box, then we say it's landed. That satisfies that fit counting element that we were talking about there. But it's also important to make sure that you record that event. And I think this was this one, so 7:13 looks like it. And so that is that same video now, but just with the bee being detected. So that's useful, and we surfaced that then on the website for folks to be able to see what's coming through the garden. Now, pollinators, of course, are a key indicator in the health of a garden. And one of the reasons why we do all of this is that urban trees in particular only have a 30% chance of living in the first year of being installed in any particular urban space, which is a horrible statistic. And in fact, only 50% make it through to 10 years. So monitoring up front and having those analytics and that data is super important for making sure that you can sustain the life of those in particular trees, but the whole urban eco space in particular. One of the reasons why it's super important comes down to money, of course, in that it costs around £60,000 per tree to install in an urban location, because there's a huge amount of planning that has to happen, and then you've got to get the permits in place, and then you've got to dig a massive hole and have the people do that, and then you've got to put the actual tree in, which is the final part of that, and then make sure that it's installed correctly, if you will, planted correctly. And if it's going to die in the first year, that's a lot of £60,000 waste that you're going to go through there. So from that point alone, never mind the benefits that these urban ecosystems give to the people that are in it, in shade and in grabbing pollutants from the atmosphere and filtering them out. All of those things are super beneficial. So that kind of gives you an idea of where we are now. I would love to be able to give a full end-to-end tutorial for this, but this is currently an Avanade product, so I can't give this away at the moment, sadly. So that's about as much information as I can give. However, the links will give you the wherewithal for you to be able to do this yourself. But again, there are quite a few steps to make that work, and it's a little bit difficult and not all that well documented at the moment. These are the links, so by all means, take a screenshot of that if you like. That will give you Label Studio, which was that open source software that allows me to be able to label the images and export them. If you want some information on the AI Hat Plus, then that link, top one, will give you that. Then if you go buy one, they're not cheap, about 60, 70 quid, maybe even up to 100 quid for the 8L version. The 26 tops version is quite expensive, but should you get one, that installation will get all of the software and hardware configured and installed. Now, inside that beautiful box was a 3D printed case. I'm not sure I'm going to be able to get this to go up, but there you are. That is what that looks like. And this is designed for the Raspberry Pi with an AI hat and a camera. So that was what I happen to have already. And so that's what I just brought down with me to the garden. And if you want to print that, that's the link to that. The Hailo model zoo and the YOLO 8 retraining instructions are there then for you to be able to go on that journey of creating a heft file, which again is not very well documented. I do have a blog that I'm not allowed to publish, sadly. But one day, hopefully, we'll get out of that red tape and I'll be able to publish that and help people. But hopefully some of this information will help folks get on that journey. I do have a series of videos on YouTube. By all means, either scan that QR code or get that bit.ly. And this is AI with the Raspberry Pi. So we do the AI kit as well as the AI camera in that as well. So by all means, go check those videos out. And that's it. Finally, though, I mean, we did have some challenges while we were doing it in that we were making a garden. So it's not just the tech that we were putting in, we were putting the tech into a garden. So that was relatively complicated. And a lot of the work we had to do in the end, we did on site, as you saw from the video earlier, with Dave busy soldering on a picnic table, if nothing else, in the middle of the back of the garden. Again, we're in a live environment here, so there's a lot of sensitivity around the use of tech in a garden, in that if you're a purist, then you're going to think that that's not going to be something that you'd want to do, a beautiful garden and put tech in it. But hopefully you saw from the walkthrough video that we kept that tech low key, and that was designed that way, so it wasn't intrusive. Getting parts and getting things on time was difficult, even to the point where I was wandering around half of London trying to find places to buy decent routers, because the router we had wasn't quite strong enough to get to the bottom of the garden through a pavilion and a metal cabinet. So things like that was interesting. And then just the internal processes we had to learn to do this, because Avanade and Microsoft did this, so it wasn't a client-led project. So we had to go through quite a lot of internal processes to try and figure out the best way to do this, some of which we're still trying to go through, as I've just mentioned about releasing software and blogs and things like that. Actually, as I said before, it's gone. The garden gets torn down to nothing, but it's not gone at all entirely. It will go up. A lot of it will go up to Mayfield Park, to the first new park in 100 years in Manchester, where we're going to reinstall a lot of this from trees and sensors up there in collaboration with Landsec. And the garden, again, was designed by Jay Arn and Tom Massey as well. So it will continue its life after that. And that's it. So thank you very much for listening to that. Obviously, if you've got some questions, by all means, ask them in the chat. I am keen that I want to carry on now and let Christophe do his section. But if you wanted to, we'll have a break while we switch over. If you wanted to go fill your water up and sort yourself out and come back just in a couple of minutes' time, we'll be ready for Christophe. So thank you very much. There we go. So Christophe, you can feel free to share your screen when you're ready. We have questions in the chat, which I see Dave has been kindly answering, and Sandra as well. Yes, nano framework for the soil sensors, absolutely. And in fact, that's another one of our very close friends in the IoT MVP community. Jose is one of the people that Jose Samoa is one of the people that created and now maintains nano framework, which is a way of getting C# code on a tiny device like an ESP32. And Michael, you said what at one point? I'm not quite sure what that was in relation to.
That was 60,000 for putting a tree in, I think.
Yeah. Yes. Yeah, exactly that. Crazy cost to put trees in urban environments. So yeah, we didn't realize that until we were on site and we met somebody who called themselves the head of trees for London, which is brilliant. What about that for a job title? The head of trees for London. So there you go. So now we will pass over to Christophe to talk about Agentic AI.
Thank you, Peter. So a nice transition. Your project was talking about talking to a tree, and this one is talking to a factory. So nice to meet you again. It's the second time we are together in this webcast, and the last one was 1 year ago, so time goes fast. So to present what I'm doing with my colleagues, so I'm Christophe Crémon. I'm the lead of Industry of the Future offerings for Avanade France. So helping all the customers in industry, especially manufacturing, to help digitalize their operations. And we started a project with my colleagues Stéphane Louge and Hubert de Florian to work on what would be the best, I would say, architecture in order to deploy an agentic AI solution. There is a lot of buzz today with new protocols, new features coming all along the way with agentic and how to deploy all those agents. So we decided to go to a real scenario. And for this scenario, we started for one we know already from the previous one from last year. You may remember, Peter, Talk to Your Factory demonstrator I was creating. So we continued on this path with the ability to understand what are the current operations going in many factories. So the challenge today for customers in manufacturing area is that you are deploying many machines, industrial equipment on the shop floor in the factory. Each machine is creating its own type of data in its own way or to write this data. And you have to be able to capture the telemetry to know if the machine, you have to plan a maintenance soon, because you see that in the past you had a lot of downtime, or you see that for the quality in terms of production, there are a lot of scrap parts and so on. So you need to collect everything at the same time, I would say, to be able to create some KPIs and to see what is going on in your line or in your factory. And so to understand what is the best action to do when there is an issue or when there is an abnormal behavior occurring on the line. So this is a specific implementation, but you can see this for any automotive manufacturer. So the example here is from Toyota. We don't work with Toyota yet, but I selected the factories from USA, France, and Japan, so that you will see that we are able to talk to the agent and various agents in order to understand what is going on in the various factories. The three aspects we see with our clients and even in our experimentations in research and development is that we need to do this in 3 steps. First, we need to unify the data. So we need to be sure that every data coming from the edge or from the factory can be ingested in the cloud. The same way you were doing it, Peter, with the flowers and the trees. So the data is from the edge to the cloud. And once the data is in the cloud, you have to contextualize. So you have to understand what is this data, what is this data point, basically. A tag can be temperature and a value 26 degrees Celsius, let's say. So you have to understand what is this data. Is it meaningful for you or not, in order to create automatic mechanism to send alerts or to do corrective actions. And then you are able to democratize the data. So once the data is available for everyone, you are able to share it across the organization. And then people are able to understand what is going on in the various operational sites you have within your organization. But the main challenge is you have 2 types of population, I would say, the OT people and the IT people. OT people stands for operational technology. So they are more on the shop floor with the machine, noisy machine, with a helmet, with gloves and so on. So it's not really comfortable, but they have to act quickly and understand what is going on with their machines and what is going on in the factory. On the other side, we have the IT people, information technology, as you may know, where we are more, I would say, comfortable in the sense we have the latest technology, everything is secure by default and so on. You have bring your own device if you want at the office, you can bring your MacBook and so on. That's not the case in the factories. So that's why we want to close the gap between OT people and IT people, giving them digital applications so that they are able to understand what is going on in their factory, in their operations all along the day. So what we decided to do is to create what we can call an agentic network, or a network of agents. So each agent is specialized on a specific task. So there is one agent that will be able to analyze what is going on the machine itself, to analyze the telemetry. One that will be able to understand which maintenance technicians are available if you have to send someone on the site, and which spare parts you have to take with you, because the bad luck is when you are going on site and you don't have the spare parts with you. So you are in front of the machine, it is not working, you cannot repair it. And the last agent is the incident agent that is able to create a ticket, assign it, and follow the escalation process. And this is very powerful against, I would say, basic ChatGPT one agent experience. Meaning that if you want to have a deep understanding on what is going on and you have only one agent, you will have to ask questions, wait for the answer, questions, and so on, for many shots to create the context, and so the agent to understand what you are trying to do. If you are using an agentic AI solution, you will use a network of agents, and each agent will work together to find the solution, but it will be faster in terms of resolution of the incident, and you know that each agent will be specialized on a specific task. In terms of solution with the Microsoft stack, we see that there are a lot of things possible and you can use. So we start from Microsoft Copilot. So the agent is inside, I would say, an application like PowerPoint or Microsoft Teams. So you can generate meeting notes, but you cannot do more than that. You don't have any connectors and so on. So that's why Microsoft created Copilot Studio. And with Copilot Studio, you can connect the agent to a SharePoint library, read the data in the PDF files, for example, in the SharePoint library. And the last one is the AI Foundry, and this is where we will focus on it today, is I would say, the build approach or the pro code approach. where we are able to customize the solution and use the latest technologies, but you have to develop almost everything by your own. So in terms of complexity, it's from left to right. You can experiment a lot of things with Copilot Studio, but if you want to go deeper in the solution, you have to build it. So in terms of LLM, so the large language models, you can call, they are in Azure AI Foundry. So they are hosted, I would say, in a data center, and you are able to call an API to call the specific model you want to work with. And then you have the agentic framework, that is I would say, the client. So Azure AI Foundry is the server, agentic framework is the client, and so you are calling the LLM with the data you want to send, and then you will have the answer back from the LLM. So basically, in terms of frameworks, we have many frameworks today. We are able to leverage. I've not mentioned everything because sometimes people use Crew AI or other frameworks. I choose the ones that are more relevant for, I would say, for Avanade, since we are working a lot with Microsoft technologies. So from Copilot Studio, that is, I would say, low-code, no-code, citizen dev approach, to semantic kernel, that is a pro-code approach with a more deep or more robust features when you want to develop. We also have AutoGen, that is, I would say, a research and development project that will be in beta for a long time. But if you want to test new features, they will be available in AutoGen. And there is also LangChain and LangGraph. I think it's one of the oldest frameworks when you want to use AI agents that allows you to create a graph of agents, and so to understand how they are working together. So this is for the frameworks. So now I will go in some specific, I would say, technologies or tools that have arrived in the last 6 months. We heard about MCP. That is not a Microsoft Certified Professional, but Model Context Protocol. That is another way, and not another way. That is a way for you when you have a client calling an LLM to give him tools where the agent is not able to do it by himself. For example, if you want to create a ticket in ServiceNow and you don't have the connector, or you don't have the logic inside the client, you will have to code by yourself everything, and then you will have a Python file to connect to the ServiceNow server, and then to create the ticket. The MCP approach is you will create a server, and this server will expose as an API all the tools that the agent can leverage. So the agent will say, for example, I don't know how to create a ticket. He will call the MCP server. He will see that there is a new method, I would say, that is create ticket. So he knows that if he's using this MCP server, he will be able to create the ticket via the MCP server. And so the responsibility of this is on the MCP server and not on the client. So it simplifies a lot the architecture, so that you have the agent, you have the inference, the LLM models running in the cloud, and then you have the MCP servers running in the cloud or running at the edge if you want, for example, to be able to extract some data from a local database in your factory. You can ask the MCP server from the factory and then have the data back to your client. So this is the first, I would say, new technology that was created by Anthropic, the company who created Claude, the model Claude. And there is a new tool that was created by Google. It is called the Agent to Agent. And this one is useful when you want to communicate across different agents. So let's say Peter is creating an agent on semantic kernel in C# running in his garden. So to check all the trees. And I'm playing with another agent in Python with a LangGraph or LangChain. And I want both to communicate. So one that is able to understand what is going on in the garden, and one that is able, for example, to trigger incidents or to automatically do the analysis of what is going in the garden. And if the agents wants to talk together, if they are not on the same framework, you have to use agent to agent. And this agent to agent protocol is again a new, I would say, API server that you will put in the middle of your architecture, so that all the agents will be able to talk together, even if they are not on the same framework or on the same language. And the language means C# or Python or TypeScript, if you want.
Christophe?
And there is, yeah.
Sander's asking, is MCP supported by every main agent? Like, is put ChatGPT version X, but I guess you mean OpenAI or in general, don't you, I guess?
Yeah, it's supported for each new modern framework. So AutoGen, Semantic Kernel, LangGraph, LangChain, Crew AI. So you can play with almost every agent framework with the MCP server. Yeah.
Okay. Thank you.
And there is a new, I would say, new joiner that is very recent. Maybe it's 2 months ago, I think, is the AGUI. So the AGUI is the Agent User Interaction Protocol. So this will simplify the connection between the agent and the front end, because you know that we see a lot of demos, MVP projects where it's one Python file with the backend and the front end, and you are executing a Streamlit application or Chainlit application. This is okay for a demo, but when you want to scale, it's a nightmare because you cannot scale a Python file, honestly. So you have to separate the logic between the agent that will handle the chat with the user, the MCP server that will handle the interaction with many services, can be cloud or edge, and the front end, so that you are separating everything as we do in all modern applications now. You are able to add authentication on the front end. You are able to add MCP authentication as well, so that you know which agent can authenticate to the MCP server. And so you are securing the full stack of the Agentic AI solution you are building. So to explain this with a schema, it's a bit EV schema, if I can say. What we implement in Azure is this type of architecture. So you will see that I wrote here a small sequence when there is an IT operator or an OT operator, as I said in the beginning. They want to have information on what's going on in the factory, or they want to create a ticket. So the IT operator in the cloud and the OT operator at the edge. So the IT operator will start with asking a question, basically. Then it will be with the front end using the chat application that everybody knows today. This application would be, I would say, a front end like React. I think it's the most commonly deployed. And this React application will talk to the A2A server, so the agent-to-agent server, to be connected to the backend. So the agent that is in LangGraph, and we have also one that is in Semantic Kernel. So that you are simplifying the way the front end is talking to the backend. You unify it, I would say, with the agent-to-agent server, regardless the framework that you have behind. It can be Semantic Kernel, LangChain, Crew AI, whatever. You will see what I have a small demo just after to show you the A2A server will expose you the agent, and so you just have to communicate with this agent. And so once you are able to reach the backend agent, so the LangGraph or the Semantic Kernel, this agent will be able to call by himself the MCP server. And so in this example, I have many data coming from machines from my factory that are sent to an event hub. And from this event hub, so event hub is a message queuing system, I would say. This event hub is connected to a Data Explorer or a Fabric, Microsoft Fabric instance. And we are retrieving data in a custom database. So what we do is we have a medallion architecture where we have the bronze data, so the one that is raw data I would say not humanly readable because it's raw data from the machine. We are processing the data in the silver layer. We are using Azure IoT operations for that to be able to contextualize the data. So we know which machine is sending the data, which types of data we want to process. And then we send the data in, as I said, Azure Data Explorer or Microsoft Fabric in a custom database. So it's a time series database. And then we have the gold layer here that we can use for application to query the data. And this is the layer that will be queried by the MCP server. That can be the Fabric MCP server or CustoDB MCP server, whatever you want. You can use some servers that are available now, developed by Microsoft available on GitHub, or you can write your own. It's really fast. And you can use the library in Python that is fast MCP. And so you are able to quickly create this MCP server by yourself. Do we have questions, Peter, in the chat before I continue to the demo?
No, not at the moment. Does anybody have any questions that they'd like to raise at this moment in time? I mean, that's quite a complicated architecture, but when you break it down into blocks, it's not too bad, is it? It's, there's the bits there. There's big blocks there that you just wire together, really.
Yeah.
For some of it, at least. What's the hardest part on that diagram?
The hardest part, I would say, is the integration front end and back end. Because when you want to be sure that the communication is fast, I would say, between the chat window and the backend and the agent-to-agent server and so on, you have lots of components to be created. Even if they are small ones, it's only containers you can run everywhere. You have to understand the message journey from the user to the data that is in Fabric, taken by the agent and then sent back to the user. So it's a complex, I would say, not philosophy, but there are multiple ops for it to make it work. So
yeah, that makes sense.
We decided for this demonstration I will show to use a long chain and long graph, especially because the observability is very important. When you want to debug an application like that, you have to understand where you are stuck, since you have one server for the front end, one server for the back end, one for the agent to agent, and you have many MCP servers depending on the functionalities you want. So if there is only an error occurred and you don't know where you are stuck, honestly. So we decided to use a long graph, and with long graph, we have this beautiful interface that may seem simple, where we can see basically the different roles in terms of agents that are working in the Agentic UI solution. So if I go back just 1 second on the PowerPoint presentation, you see the different roles from supervisor, machine expert, maintenance agent, and incident agent, and they are working together to give back the answer to the client. So this implementation is supervisor led because the supervisor will handle the answer for all the agents before sending it back to the user. So in terms of deployment, you create a graph in long chain, long graph. In long graph, you create the graph, and then you are able to see the different roles and how they are communicating with each other. And once you created the graph, I will show you with the demo, you are able to trace all the calls you sent to the different agents and LLMs and tools. So LLM is the AI Foundry model sitting in Microsoft Data Center running, let's say, GPT-4o. There is the agent. Then there is the tool, and the tool is the MCP server that is able to query, for example, your database or to create a ticket in Jira or ServiceNow, depending on what you want. So we have this agent. We have the agent-to-agent server. So it's really basic. You see there is a card, and this card explains what kind of agents you have and what you can do. So you have the skills here in terms of what is possible with this agent. And you have the name of the maintenance agent, the incident agent. You can do also a KPI analysis. And so when the server will trigger this agent-to-agent server, it will understand who is it talking to. So it will understand what it can do or not, given on this card. It's like an identity card for an agent, basically. And so in the demo, we created a mockup with a front end and specific roles for many people in the factory. So if I'm the plant manager, I can have all access to all the modules. I will go in my application, and there from the chat window, I will be able to ask questions to my agents. So I will show you, for example, if I want to report the overall equipment effectiveness, so if all the equipments are fine in my factory, I want to check per site last week what is going on in my factory. I will ask to the agent, then the agent will send this question to the machine expert, and I will have the results. So if I go to the agent conversation lineage, I can see that the supervisor has received the user request, routing to the machine expert, processing the data, and then sending back the data. So I see here that the worst site is in America, Greensboro, where the overall effectiveness is lower than the other ones. And if I go in the observability window, so what's provided by Longsmith from LangGraph, as I was explaining earlier, I will see here, if I go to a specific trace, so I will take the last one I was just doing. I see that I asked please report overall equipment effectiveness per site last week. Then I was transferred to the machine expert, and then I had to use a tool. And so this tool is the MCP server that is able to query for me the data that is in Microsoft Fabric or in my Azure Data Explorer. Because we know that people in the factory are not database admins, so they are not keen to create complex queries in the tool. So when we use this, we can see that when we want to have a view on the tool, we can see what is going on the tool. We have the result from the tool itself. So we see the data that is coming from the database, and it's real time. It's real data coming from the database. You can see with the timestamp here. He was able to look at the data from the last week. So that's why it's taking 7 days back. And then he's sending back the response to the supervisor, and then the supervisor will send back the response to the user. So it's a full end-to-end loop on Agentic AI. Is many topics that I shared, but as you see, it's, I would say, more complex than a Python file with backend and frontend in the same code, as I was showing last year with you, Peter. Now it has evolved to a more robust solution when you want to scale the agents, you want to scale the front end, you want to scale the MCP server, and so on. So happy to share it with you. It's an ongoing project because we have many things to improve in terms of latency, cache, and so on. But yeah, to show you what are the building blocks to make it work at the end.
Awesome. Michael asked about the Fast MCP project. I put a link in the chat there on that question, but that's just an open source Python project, is it?
Yeah, exactly. Everything is open source, and I'm using LangGraph for this because we started with a semantic kernel. Even if we are continuing with semantic kernel, the observability tools and the waterfall approach when you want to debug what is going on in your application. For example, you want to know how long it takes to call Azure and then to have the feedback and so on. We have some tools with Microsoft, but today we don't have such beautiful interface. So that's why we decided to be, I would say, lazy and use this kind of solution. That is open source as well. LangGraph is open source. The MCP servers are open source. Agent to agent is open source. So yeah, everything is it's not free because you have to host the servers somewhere in the cloud. So you will pay for the hosting and for the using those components. But at the end, you will end with this type of architecture. And as you see, you will have agents, tools, and the front end for the user.
And does that answer your other question there, Michael, in that the UI we're looking at is LangGraph? That's what we're looking at there, is it?
Yes. Yeah, deleted my question. Yeah.
Yep. Craig asked, where are the MCP servers deployed? Are they in Foundry?
No, they are in Azure. So
Okay.
we deployed Azure Apps containers in the cloud. And
okay.
so we are talking to them, if I can say. And so we are using this as a container app instance today. And in the future, we'll use Kubernetes server. So I can show you quickly what is it. It's very easy to set up. You have this kind of deployment. So you have for example, the ADX MCP server, and this is running and is part of app container environment. And so the app container environment, you will see all the MCP servers we are using. And so we are just using them as endpoints with HTTPS URL.
I like it. Dave Bostock has asked, can we do any local hosting like LM Studio or Olama for local testing and not burning your credit card?
Yeah, I'm trying to have maybe you can help me, Peter, on this NVIDIA Jetson Orin for the inference, because I tried to set up and it's a good question from Dave. Thank you. I tried to set up Olama on a MacBook Pro with a M1 Pro chip. It's an older one, but the inference latency is still high, so I have to wait for the new technology or the new hardware to be available. And I think that NVIDIA Jetson Orin is a good candidate, but it's out of stock everywhere. So I have to find one. And then we have some scenarios that may involve edge solution as well, because as you see on the lower right-hand part here, we may need for some customers in factories where there is intellectual property, when there is specific proprietary data, to talk to the data, but sitting at edge. So the client has to deploy as well an inference server. This is what I call an inference server for the local LLM to be able to execute. Yeah.
Love it. Love it. Craig says that it looks quite reminiscent of ChatDev or Crew AI as well. There, I guess that's the interface you were talking about there, the LangGraph one.
Where is it, the Crew AI question? Sorry.
It's that it looks like ChatDev or Crew AI is just slightly up there. It just looks reminiscent of that from Craig.
I don't know ChatDev yet, but no, it's a custom development here with a React frontend and a Next.js and TurboPack as well. And the backend is A2A server, so agent to agent server calling a LangGraph agent. I'm not using Crew AI because there are some companies like that. They are going to make proprietary solutions. I think they are in a model where you have all the features when you are using the cloud solution, even if LangChain is doing almost the same path, I would say. So that's why we decided to use LangGraph. But in the future, we may use semantic kernel once the observability features are there, because otherwise it's hard to say if your application is fast or there is performance if you are not able to track everything in a convenient way. So that's why we use the long graph today.
Sounds good. Have we got any idea on cost of something like this? That's a very awkward question, but t-shirt size it for me.
Can share the cost of the resource group we have in Azure. It would be easy to get it. Let me look at it. The main cost we have is on the Azure Data Explorer server, because it's the one that is storing all the data from the different factories. So we have simulators sending data for all the different factories. And we have some we have some storage, so it's almost so the cluster itself is 340 euros a month for the full database. I think you can play with a Fabric trial and have the same results for free, but for 60 days, I think now. And then the containers, it's 15 euros a month for the container running the MCP server. So it's cheap. So the highest cost is not on the LLM itself when you are calling everything, because it's still very low. So I don't see it in the cost analysis. I have to deep dive on it to see it, to be honest.
That's interesting, isn't it? And is that an ingestion or a storage cost, do we think?
I think it's ingestion because it's in real time. So it's we have many datas coming with the simulators. I think it's 1,000 message a second. So that's why it's pushing a lot of data.
Oof. Wow. Okay.
And you are paying for the ingestion scale.
Yeah, that'll make sense. Any other questions? Larry, you've joined at the end, unless you've rejoined. There you are. Hello, you've joined at the end.
Hello,
there is a YouTube link.
Yeah, I'll probably have to check on YouTube. I had a school open evening, so that's where I was. I just see
nice to see you though, Larry.
Just at least say hello. Hi, Dave, as well.
Hello.
Yeah. I've just put a link into the YouTube, so you can absolutely catch up, and that goes for anybody else that joined late or whatever, or just wants to go back and grab links or whatever. The YouTube link will help with that. More curiously would be the number of images required for training, especially. Oh, yeah, that's a question on my stuff there. Yes. Yeah, there was quite a few that I wanted to train on when I was doing it. It took me quite a few hours. I probably trained more than I needed to be fair. Question on my side there. Any other questions there for Christophe?
No questions from me. I've got like a notepad full of things to go and look at though. Pretty much every sentence you said I've scribbled down. Find out what this is.
It's awesome. And the previous iteration of this, which you could almost not call a previous iteration because it's so different, was awesome as well. And I know that this has taken you quite a lot of time to refine and figure out and get right, and you must have learned a heap.
Yeah.
How much of this is going to be open? I know the components are open source, but how much of this is release?
We have to check. Honestly, the question today is, can we do this as an asset for Avanade that can be reusable across different clients? And if it's the case, I would say the intellectual property will be Avanade. But since we are leveraging many open source components, since when you have the recipe, you can replicate it. So I may create another project with I would say non-Avanade intelligence in it, and we are working also on many different industries. So this is for manufacturing, but we could do the same with retail Agentic AI. So there is one that will look at a photo of you, for example, one that will look at the inventory in the ERP, and then you are able to order the specific gene you would like to have during the during the summer period or the winter period. Sorry. So it depends on many scenarios, but I'm still thinking about open source because I think it's helping a lot of people to assemble all the bricks. So I will discuss with my management on this, and I think I can be able to share a bit of the recipe as a GitHub repo.
Yeah, similar to the AI Pollinator trap, because they might want to productize it. It's difficult to share very much, which is kind of frustrating from my personal perspective, because that's what I tend to want to do is share this, and I'm imagining that's the same for Christophe. It's kind of an MVP thing as well, but yeah, you have to sort of bear in mind that there's money behind this, so that's the reason why. Sadly,
and the most complex thing I would share with you is that you have to see that the technology is moving almost every 2 days or every day now. So every package you have to fix every version. This is the best practice because you will break everything at some point. So don't use every time the latest version. You fix all the versions in Python, for example, and then you are able to debug one by one all the different components talking together. But sometimes the documentation is not here. So to be honest, sometimes I had to leverage on Claude Sonnet 4, the model from Anthropic, with GitHub Copilot, because I was not able to easily connect all the APIs and so on. So sometimes you need to do 15 lines of code, but you are working on it for 2 hours. So I was okay. Maybe I can raise sometimes the GitHub Copilot agent to help me on that. So yeah, it's really helpful
yeah.
for that.
I did the same thing. So I gave a talk on just RAG, and I wanted to update all of that. And yeah, I didn't have that many packages because it was using Azure AI Search and OpenAI and then a few other bits. But yeah, it changes rapidly, and they don't care about breaking stuff at the minute. They'll just put breaking changes in there, and you got to rewrite half your app.
Yeah.
So,
and I see the point of Dave. What's confusing as well is that OpenAI is not open at all. It's one of the last companies where the model is not shared, so you don't know what's the data set, or they are training the model, and so on. So whenever it's possible, I'm using models from, for example, Llama or open source models, even from Hugging Face. That is, I would say, the GitHub for the models. So everything is in Hugging Face. You have thousands of models available. I don't know if you know this site, but it's amazing. You see all the models in Hugging Face. I think it's one. It's browse 1 million plus models. So you have 1 million. So if you want to play with it, all those models are open source. Sometimes you have license to read, and if you are using the model, but you sometimes you may be able to deploy also applications where you are using the best model for the vision, one for the text, one for the audio, and so on. So you can take a long time to benchmark everything by your own. So Hugging Face is a good site for this.
yeah, I've been on there before and then left because I didn't know what I was looking at.
It's pretty overwhelming.
Yeah. So sometimes you see models from companies, and sometimes you see models from people. So you have to check also what's possible. And the best is as I say every time, is to start small. So if you want to use your own model at the edge on your own hardware, don't use a model with when you need 256 gigabytes of memory just to read that a CSV file, So use the smallest one. And then from the smallest one, I know that there is one from Hugging Face that is small, this one. And you see in the files and version that it's 40, almost 5 gigs of RAM. Because when you will download it, it will stay in memory. So you can start small with such models. Don't choose the you have to have the hardware to do it. If you want to use a model with 256 gigabytes, I think it's the one from Databricks. It is
that
really
video
big.
RAM as well, or standard RAM? Is that graphics card RAM?
It's graphics card memory, and if you don't have enough, it will be on the memory from your computer. So you see that this one is bigger. You see all the safe tensors you have to download. I think it's 250.
Jesus wept.
Yeah.
Yeah, I'm not doing that.
Yeah, I've not got a bad machine, but it's not in them leagues.
If you use LM Studio, though, it does a lot of that for you. It's like my dummy's guide to playing AI locally. And it would
What
even run on
studio,
my
sorry?
LM Studio,
LM Studio. Right.
or Llama if you want a text interface.
Yeah.
LM Studio is a lot easier to use.
Yeah, Llama, you can use it on a Mac as well. Yeah, it's working well. Exactly.
Yeah. If you hop back to the Hugging Face, it actually has a filter on the left. So LM.
And you see, LM Studio is a good tool as well if you want to play with your own data. Yeah, exactly.
Yeah,
Thank you.
You can download lots of different. If you on Hugging Face, it actually has a filter on the left that will let you pick. So yeah. Over there, if you look
LM Studio. Yeah. Okay.
So that'll show you what's fully compatible with those, and then you can just pull those down into your local machine.
Yeah. Okay.
And again, you're then looking at how big they are, and if you've got enough.
Okay.
If you've got enough memory.
Thank you. So you are going from 1 million plus to 132,000 models to play with. So it's still
a bit more manageable.
Yeah. One by one, just for the weekend.
Oh yeah, love it. Cool. Any more questions? No. Well, thank you very much to. Well, I mean, I'm not going to thank myself, but to Dave for helping out with my selection of that, and to Christophe for his awesome talk there. Thanks to everybody who came along. Some faces I recognise and some faces I don't. So thank you for joining. It was great to see you. We will be having a break. We've had a break anyway, as you'll recognise, because we've not had one this year until now. And that's just generally because this year has been crazy for me. So you blame me for that. But come September, I'm hoping that we'll have some more people come back and talk. If any of you folks do want to speak at any of these events, you are more than welcome. We'll accommodate any level of speaker as well. So if it's your first time, we are a super friendly group of folks.
Let's see how we do with this big notepad of keywords to research for the next 2 months.
Yeah, exactly. Yeah, I would love that. So do get in touch. You'll find me on Twitter, X, whatever you want to call it, or LinkedIn, or any of those places. Just reach out. Love to speak to you about that. So hopefully we'll be back in September, and the same for our sister group .NET Knots. Hopefully there'll be something there. And if you're based in and around Loughborough, then we will also have some events at another group I run called Lati, where I think in September we've got the founder of a guy who's created some almost indestructible earbuds for sports folks. So we're having a talk about that. So with that aside, again, thank you to Christophe and Dave for speaking on their parts there. Absolutely amazing. And we'll catch you all again soon.
Hi.
Thank you.
Thanks a lot, guys.
Thank you.
Cheers, folks. Bye.
Bye-bye.
Bye.
Thanks for coming, Larry. Appreciate it.
Oh, I wanted to join, but then I just found out that I've got to go to the school's open evening thing.
Yeah.
So I did go there.